All right, welcome back, everybody. In this session, we'll be talking about conversion factors and dimensional analysis and our continuation of Chapter 2. So conversion factors are ratios that specify how one unit of measurement is related to another. So Chapter 2 is all about measurements. We previously talked about what a measurement is, as well as the base units of the metric system. And then we talked about significant figures. And in this section, we're going to be bringing those two concepts together in order to use conversion factors to perform calculations. So we'll be using conversion factors to convert between different types of units, like from inches to centimeters or meters to micrometers. And we'll use the conversion factor that relates to two units by writing the relationship as a ratio. And so there's always two ways to write each conversion factor. And again, a conversion factor just shows how two units are related to each other. So for example, if we want to convert between minutes and seconds, you can write this mathematical relationship where 1 minute equals 60 seconds. And that is a conversion factor. We're showing how minutes and seconds are related. So that conversion factor, 1 minute equals 60 seconds, could be written as two different ratios shown below. 1 minute per 60 seconds, or 60 seconds per 1 minute. And so anytime you see this type of conversion factor, we have 1 minute equals 60 seconds. That's a conversion factor. It just shows the relationship between minutes and seconds. It could always be written these two other ways. And these are ratios, again, showing that relationship. In 1 minute, there are 60 seconds, or in 60 seconds, there's 1 minute. So the metric system prefixes can be used as conversion factors to convert between units in the metric system. So we know from the prefix table that 0.001 liters, or 10 to the negative third liters, equals 1 milliliter. And that's from that prefix table. So we could write that conversion factor from the prefix table. And in our prefix table, we see that as, when you look it up in the prefix table, you look up this conversion factor. But we know from scientific notation that 10 to the negative 3 is the same as 0.001. So this conversion factor you could write as two different ratios. 0.001 liters is equivalent, or per 1 milliliter, or for every 1 milliliter, there's 0.001 liters. And just a note on this conversion factor, I like to always show this one and point out that this is also commonly written as 1,000 milliliters equals 1 liter, so that your ratios are that there's 1,000 milliliters per liter, or in 1 liter, there's 1,000 milliliters. And to write it this way, box down here, all we did is we took this conversion factor up here, 10 to the negative third liters per 1 milliliter, and multiplied both sides by 1,000. So 10 to the negative 3 turns into 1, and 1 turns into 1,000. Some people find it easier to remember 1,000 milliliters per liter instead of 10 to the negative third. So all conversion factors could be written as two different ratios, and you can use the metric system prefix table to convert between any prefix and the base unit in the metric system. So again, here's our prefix table, and to remind you how to use it, and this is shared on Canvas on our class website. You can also use the one that's in your textbook. But to use the one that I shared, you just fill in the blanks with the base unit that you're interested in. So let's say we're interested in liters. So 1 megaliter is 10 to the 6 liters. And so this is our conversion factor here to convert between megaliters and liters. And so we could write this 1 megaliter equals 10 to the 6 liters, which could then be written as two different ratios. 1 megaliter per 10 to the 6 liters, or 10 to the 6 liters for every 1 megaliter. So any of these conversion factors on the metric system prefix table could be written as two different ratios. And so you'll get a lot of practice doing this. We're going to be using the metric system in this prefix table throughout the rest of the course to convert metric system units, which are used in chemistry. Okay, so when working with conversion factors are used to convert from one unit of measurement to another unit of measurement. So because we're talking about measurements when we're working with conversion factors, we have to think about sig figs because measurements have some inherent uncertainty, which means there's an estimated digit in there, which means that we have to count the sig figs. And we went over counting sig figs previously in the previous two sections. So if you need to go back and review that, now's a good time to do that because from this point forward, you'll need to be able to quickly count the number of sig figs in a measurement and then use the rules of sig figs in calculations like multiplication, division, addition, subtraction to properly keep track of the number of sig figs in calculations. So for unit conversions within the same system of measurement, so if you're converting a metric unit to another metric unit like centimeters to meters or liters to megaliters, or if you're converting within the English system like ounces to pounds or inches to feet, those conversions are based on definitions within that measurement system. Like by definition, there's 12 inches in a foot. And so that would be an exact number. And so the sig figs are infinite. And anything on the prefix table is also by definition. By definition, there's 10 to the 6 megaliters, 10 to the 6 liters in 1 megaliter. And so anything metric to metric or English to English, they're based on a definition. And so those conversions use exact numbers. And so the sig figs, when you do those conversions, are infinite and will not impact your final answer. So here's a bunch of examples. 3 feet per yard, that's an English to English system conversion between feet and yards, 16 ounces per pound, 10 to the 3rd meters per 1 kilometer, 10 to the -1 liters per deciliter. Those are all exact conversions. And so when you use one of these conversions in a calculation, the sig figs from the conversion won't impact your final answer. When you're converting back and forth between the two systems of measurement, like from an English system unit of measurement like feet to a metric system unit of measurement like meters, those conversions require a measurement in order to perform the conversion. And so any conversion between the systems of measurement, like English to metric or metric to English, are going to involve inexact numbers, measured numbers that have some uncertainty. And so because of that, you have to take sig figs into account. There's one exception. In chemistry, we love to tell you the rules and then we tell you all the exceptions to this conversion between English and metric systems, always involving inexact numbers, and therefore you have to keep track of sig figs. The exception is that the conversion between inches and centimeters is considered exact. But all the other English to metric system conversions, you'll need to keep track of sig figs. So for example, there's 453.6 grams in 1 pound. That's an English to metric system conversion to go from grams in the metric system to pounds in the English system. And to come up with that conversion factor, somebody took 1 pound exactly and put it on a metric system scale that read in grams and measured how many grams 1 pound was equal to. Same thing with the next one, milliliters to fluid ounces. To get that conversion factor, what was done at one point was exactly 1 milliliter was put into an ounce measuring device, and we measured how many ounces 1 milliliter was equivalent to. So because there's some measurement involved when you're converting between the English and the metric system, those conversions are going to have sig figs that you have to keep track of. But above, if you're converting within the same system, metric to metric or English to English, for this class, we're going to consider all of those exact conversions. Okay, so here's our most important conversions, and I'm going to put the most important ones in a red box. These are the ones you're going to be using over and over again. And if you either jot down or print out the metric system prefix table and conversions kind of cheat sheet I gave you on Canvas, all of these are on that. So for length, the one we're going to use over and over again is that 1 inch equals 2.54 centimeters. And we are going to consider this an exact conversion in this class. So because this is an exact conversion, even though it's between the metric and the English system, the sig figs are infinite on it. For mass, between pounds and grams or pounds and kilograms, these are the two we'll be using. 1 pound equals 454 grams. 1 kilogram equals 2.20 pounds. And then for volume, between quarts and liters, 1 quart equals 0.946 liters. And so again, anytime you're using these conversions between metric to English or English to metric, you'll need to pay attention to sig figs, except when it's between inches and centimeters. That one will be exact. Okay, so let's do just a little thought exercise here. Pause if you want, but brainstorm 3 to 4 conversion factors that you know from everyday life. I gave the example of, minutes and a second. There's probably several more that you already just kind of know, from everyday life, from cooking or working or building, whatever it is you like to do. There's probably some conversion factors involved in that. So brainstorm 3 to 4 that you know. Write each one down using an equal sign to show how they're related, and then write each one as the 2 possible ratios. And this is just to give you some practice getting comfortable with taking a conversion factor that's written as an equation like this and converting it into the 2 possible ratios. So give yourself a minute here to brainstorm 3 to 4, write them down to get yourself really familiar with expressing conversion factors as these different mathematical relationships. Okay, so now we know how to write conversion factors. What do we do with them? Well, we're going to use them to solve problems. And to do that, we use a problem-solving strategy that's called dimensional analysis. And the key to dimensional analysis is you use the units and conversion factors as a guide to setting up your problem and getting from the information that you're given in like the word problem to finding a plan to get to what you want to solve for. And units are the key. Units will guide you from your starting point to the ending point. And by checking your units as you work, you can make sure that you set the problem up correctly and that you're arriving at the correct answer. So in dimensional analysis, units are treated the same way as numbers. They can be multiplied, divided, canceled. And so just like a quick math review with numbers, let's say you multiply 3 numbers together, 3 times 3 times 3. Another way to write that is 3 cubed. 3 multiplied by itself 3 times. We do the same thing in dimensional analysis with units. So if you have a number with centimeters times centimeters times centimeters, that's the same as centimeters cubed. Same thing with multiplication and division. With numbers, if you have 5 times 2 divided by 5, the 5s cancel out, and the answer is just 2. We do the same thing with units. If you have milliliters times grams divided by milliliters, your milliliters are going to cancel out on the top and bottom of the fraction, the numerator and the denominator, and the unit you're going to be left with is just grams. And so the general strategy for unit conversions and dimensional analysis is that you take your information that you're given and you use a conversion factor to get rid of the given unit to cancel it out in the numerator and denominator, so that what you're left with at the end of the conversion is your desired unit, what you're trying to find. And again, units cancel out just like numbers. So a unit in the numerator, if you have that same unit in the denominator, it will cancel out. So we're going to be using those conversion factors, and that's why it's really important to be very comfortable writing conversion factors as those 2 different ratios, because what ratio you use is going to depend on what you want to cancel out and what you want to solve for. And so you always want to set up your conversion factors so that the unit you want to get rid of cancels out and you're just left with the unit you're trying to solve for. So when you have a complex unit conversion, there's this problem-solving strategy that works really well. We use it here in this class as well as in the higher level chemistry classes. So you start by sorting the information in the problem. You're going to get a lot of word problems, which can at first seem a little confusing when you're reading the problem and you're trying to figure out what information is important, what are you trying to solve for? You just need to kind of sort everything out to begin with. And so the things I do is I always figure out what values and units am I given, and then what do I want to find? Then you come up with a strategy or a plan. And so we're going to work on drawing a simple map to visualize how you go from your given values to what you want to find or solve for. And so I'll use like a box or, something written in larger letters to represent the key values you're going to calculate. And then I typically use an arrow to represent a computation such as a unit conversion. And we'll go through examples of this. Then once you've sorted your information, you know what you were given, you know what the problem is asking you to find, you sketch out a simple plan. After all that, you're ready to set up your equations and plug in your given values and conversion factors. Because you want to make sure that your plan, step 2, is a good plan before you're taking the time to plug things into your calculator and solve the problem. And then of course, you always want to go back and check, did your units cancel out correctly? Does the answer make sense? And do you have the correct number of sig figs in your final answer that you're writing down or reporting? Okay, so let's do some practice problems. So let's set up a conversion factor and use it to perform the following unit conversion. We have 6.75 centimeters and we want to convert this to inches. And I give you the conversion factor, 1 inch equals 2.54 centimeters, and that is an exact conversion. So we're given 6.75 centimeters and we want to find inches. Our plan is to go from centimeters to inches. And I could draw boxes around these to show these are the key values. We're starting with centimeters and we want to go to inches. And then my arrow shows the calculation I'm going to do, or my conversion I'm going to make. And what I like to do is jot down the conversion factor below. So we have 1 inch equals 2.54 centimeters. So in our problem, we're starting with centimeters and we want to get to inches. So we could write the conversion as 1 inch for every 2.54 centimeters, or for every 2.54 centimeters, there's 1 inch. We want to pick the ratio that's going to cancel out centimeters, because we're starting with centimeters, and only have inches left at the end of the conversion. And we want inches to be in the numerator. So in order to get centimeters to cancel out, we have to pick this conversion factor. Because if we multiply centimeters by this conversion factor, we'll have centimeters in the numerator, our starting value, and it will cancel out with centimeters in the denominator here, and we'll be left with inches. So our conversion factor is 1 inch for every 2.54 centimeters. So now we're actually ready to solve. So we're going to plug in our values. So we have 6.75 centimeters times our conversion factor for every 1 inch. We have 2.54 centimeters. We want to check our units. You always want to check your units once you've set this up to make sure things cancel out, because you wouldn't want to take the time to plug this into your calculator if it's not set up correctly. So centimeters and centimeters cancel out, which all we're left with is inches, and inches is what we wanted to find. So we can put a smiley face there. So we set the problem up correctly, and this is using dimensional analysis to guide us through the problem solving process. We want to make sure that all the units we want to get rid of end up canceling out, and we're only left at the end of the operation, end of the problem, with the units that we're trying to solve for. Okay, now we can plug it into your calculator. So 6.75 times 1 divided by 2.54. Let me just check what I got. I get 2.6574 and so forth on my calculator. So now what you need to do is, remember, calculators don't know about significant figures. We as humans have to take the answer on our calculator, apply science to it, and round this final answer round this answer to the correct number of significant figures. So in this problem, everything is multiplication or division. We have 6.75 times 1 inch divided by 2.54 centimeters. So we're going to just follow the rules for multiplication division. And the rules for sig figs for multiplication division says that your final answer is limited based on the number that had the fewest sig figs. So we're going to count the sig figs in each number. Here I have 3 sig figs in 6.75. And in my conversion, 2.54 centimeters per inch, that's one of those exceptions where it's an infinite number of sig figs. Usually between the metric and English system, we would have to count the sig figs. But the inches to centimeters conversion has infinite sig figs. So I'll just put infinity symbol over that one. So the fewest number of sig figs is 3. So my final answer should have 3 sig figs. So I'm going to round it at the 5. That's my last sig fig. We'll look to the right. It's a 7. So the 5 should be rounded up to a 6. So the final answer that you get is 2.66 inches. So again, that problem solving strategy, we identified what we were given. We identified what we wanted to find. We came up with a plan, kind of sketched out how we were going to get from our given value to what we wanted to find using unit conversions. Then we set up the problem with our numbers and our units. We checked that our units canceled out to give us our ending value that we wanted to find. And then we performed the problem, did the calculation on our calculator and wrote down what our calculator displayed. But then before reporting our final answer, we had to apply the rules of sig figs to round the calculator answer to the proper number of sig figs. Okay, let's do another one. Let's go from 2.5 liters to microliters. And I give you a big hint here from the prefix table, 10 to the negative 6 liters equals 1 microliter. So we're given 2.5 liters, and we want to find microliters. So I'm going to set up a little plan. I'll plan over here, actually. So I'm starting with liters, and I want to go to microliters. So this is going to be a conversion that involves the metric system prefix table. And from the prefix table, we get this conversion factor. So I want to use the conversion factor so that liters cancel out and only microliters are left. So my conversion factor could be written 10 to the negative 6 liters per microliter, or microliter per 10 to the negative 6 liters. You can imagine there's ones there. So in this problem, I want to cancel out my liters and end up with microliters. So I'm going to use the conversion factor 1 microliter is equivalent to 10 to the negative 6 liters. And so now that I have my plan, I'm ready to solve and plug some numbers in, check my units. So we start with 2.5 liters times our conversion factor for every 1 microliter. There's 10 to the negative 6 liters. Now I want to check my units, because before I take time to plug this in, let's make sure it's going to work out. So liters on top cancels with liters on bottom. The only unit I'm left with is microliters, which is what I wanted to find, so we can feel comfortable that we set the problem up correctly. So now you're ready to plug it into your calculator. So you do 2.5 times 1, which is just 2.5. So you can just do 2.5 divided by 10 to the negative 6. And so you end up getting 2.5 times 10 to the negative 6 liters. We always want to check our sig figs. In 2.5, our starting value, we had 2 sig figs. And in our conversion factor, it's metric system microliters to metric system liters within the prefix table. So that has infinite sig figs. So our final answer should have 2 sig figs, which it does. So 2.5 times 10 to the negative 6 is our final answer. Okay, let's do another one. So this one's set up more like a word problem, which is what you'll see more often. So a CSI team recovers 2.34 milliliters of a suspicious liquid at a crime scene. The team needs to log the evidence in units of liters. What number should they write in the evidence log? Okay, so in this problem, our given is that the CSI team had 2.34 milliliters of liquid. So we're given 2.34 milliliters. They need to log the volume of the liquid in their evidence log in units of liters. So we want to find liters. So we have to come up with the plan. So we need to go from milliliters to liters. And we can look up our conversion factor to go from milliliters to liters using the prefix table. And from the prefix table, 10 to the negative 3 liters per 1 milliliter. And I know I want to set up that conversion factor ratio this way because I want milliliters to cancel out and I want to be left with liters because that's what I want to find. So now I'm ready to solve. So I'm going to plug in my values, 2.34 milliliters times 10 to the negative 3 liters per 1 milliliter. This is a good time to check your units. Milliliters and milliliters cancel out. You're left with liters, which is what you wanted to find. So you set things up right. And so you end up getting 2.34 times 10 to the negative 3 liters. Last thing you always want to do is check your sig figs to make sure when you report your final answer, it has the right number of sig figs. So we started out with 3 sig figs in our given value, and our conversion factor, because it was metric system to metric system, just in that prefix table, had infinite sig figs. So our final answer should have 3 sig figs, which it does. Okay, so next we're going to talk about how to do unit conversions when you have units that have to be converted in both the numerator and the denominator. So some measurements are going to involve units with a numerator and a denominator part, and so you might need to convert one of those units or sometimes even both of those units. So you'll set up this problem like any other unit conversion problem. You sort your information into what you're given and what you want to find. You come up with a plan, you solve, and then you check your units, check your sig figs. Does the number make sense? Were you expecting it to be larger or smaller? And does that agree with what you calculated? What I like to do is I plan how to convert the numerator unit to the desired final unit. And then I convert the denominator unit to the desired final unit. And you can do this in either order. You can do numerator first or denominator first, but I kind of pick one to start with and I convert one of them to what it needs to get to. And then I convert the other one. And that kind of just, for me, helps me keep track of where I'm at and not get lost in the problem. Okay, so let's do one of these. So the human stomach produces approximately 2,500 milliliters of gastric juice per day. What is the volume in liters of gastric juice produced per hour? Okay, so let's sort our information. We have 2,500 milliliters of gastric juice per day. So that's our given. So we're given 2,500 milliliters per day. And then what we want to find is liters per hour. So we want to find liters per hour. So this is a problem where we have units in the numerator and the denominator, milliliters per day, and we're going to need to convert milliliters to liters, and we're going to need to convert days to hours. So we're going to do a unit conversion in both the numerator and the denominator. So let's come up with a plan. So we're starting with milliliters per day. Those are our starting units. And the first thing I'm going to do is I'm going to convert milliliters to liters. So after that conversion, I'll have units of liters per day. And so to convert milliliters to liters, we use the prefix table. There's 10 to the negative third liters per 1 milliliter. Okay, so I've got my liters in the numerator, which is what I want to find, so I'm good there. So the next thing I need to do is I want to convert days to hours because we need hours in the denominator. And once I do that, I'll end up with liters per hour, which is what I'm trying to find. And so my conversion factor to go from days to hours is that for every 1 day, there's 24 hours. So now I have a plan to go from milliliters per day to liters per day, and then from liters per day to liters per hour. So I'm going to set this up in my actual equation. I'm going to see if I can move some of this here. Give us a little bit more room. Okay, there we go. We're going to move our plan just over here. Okay, so let's write our solving in black to keep it a little bit so we can tell what is what. So we started out with 2,500 milliliters per day of gastric juice. And then based on our plan, we want to convert milliliters to liters using our conversion factor from the prefix table. So 10 to the negative 3 liters per milliliter. And then our next conversion factor, we want to take what's currently liters per day and convert it to liters per hour. So in every 1 day, there's 24 hours. So let's check our units to make sure our givens cancel out and we're left with what we want to find. So milliliters and milliliters cancels out. Days on the bottom here in the denominator cancels out with days in the numerator. So all we're going to be left with is some number with units of liters per hour. Liters per hour, which is what we want to find. So we know that we set up these conversions correctly because we ended up with the right units. So that's how dimensional analysis works. If you set it up correctly, by canceling out units, you can double check that you didn't mix up a ratio, didn't forget something. Because if your units end up correctly, then you're on the right track and you didn't miss a step. Okay, so let's plug it into our calculators now. Give myself some more space. So I end up getting, let's see, 0.10416, and it just kind of goes on my calculator. So now that we got an answer on our calculator, we need to be good scientists and round that to the right number of sig figs. So I'm going to go back and count my sig figs. So in 2,500, we check this number in our problem statement. There's no decimal point. So that means these 2 zeros here are not significant. They're just placeholders. So we only have 2 sig figs in this number. 2 sig figs. And then per day, day is an exact number, so we don't have to worry about the 1 down here. It doesn't matter because it's an exact per day. So 2 sig figs in there. Our next conversion is within the metric system prefix table, so that has infinite sig figs. 24 hours in 1 day, that's a conversion factor that is, by definition, there's 24 hours in 1 day, so that has infinite sig figs. So all of this is multiplication division based math, so our final answer should be rounded to 2 sig figs. So the 0 is our last sig fig. We look to the right, it's a 4. So we don't need to round. So our final answer is 0.10 liters per hour. Okay, let's do another one with a numerator denominator type of question. So one ibuprofen liquid capsule contains 200 milligrams. You notice I put a decimal point there with the 200 milligrams of ibuprofen. If one dose of ibuprofen is 3 capsules, how many ounces of ibuprofen are in a dose? And I gave you the unit conversion to go between ounces and grams. So let's use our problem-solving strategy. So we are given 200 with a decimal point milligrams per capsule. One capsule contains 200 milligrams. We're also given that one dose is 3 capsules. And then we want to find ounces per dose. How many ounces of ibuprofen are in a dose? So our plan here is going to be to go from, we'll write this over here so I have a little bit more room. Our plan here is to go from milligrams per capsule and then we can use, this arrow might actually be more confusing. We can use our other piece of given information that in one dose there's 3 capsules to convert from milligrams per capsule to milligrams per dose. So we want to go from milligrams per capsule to milligrams per dose. And we're going to use this given information as the conversion factor between capsules and doses. So there's 3 capsules, I'll just say 3 caps per 1 dose. And that will cancel out capsules top and bottom, and we're left with dose in the numerator. So we're getting close to what we want to find. We now have dose in the numerator, or sorry, in the denominator. The next thing we want to do is we need to convert milligrams, which are currently on top of our fraction, to ounces. So we get to a final value of ounces per dose. So we're given, another one of our givens, 1.00 ounces equals 28.3 grams. We're given the conversion factor between ounces and grams, but we're not given the conversion factor between milligrams and ounces. We want to end up with ounces, but we can't go straight from milligrams to ounces. What we have to do first is go from milligrams to grams, and then we can use this conversion factor to go from grams to ounces. So we're going to use the metric system to go from milligrams to grams. So we'll end up with grams per dose at the end of this conversion. And there's 10 to the negative 3 grams per milligram from the prefix table. And then our last conversion is we're going to go from grams to ounces. So we end up with ounces per dose, which is what the problem asked us to solve for. And now we can use this conversion factor, 1 ounce equals 28.3 grams, to go from grams to ounces. So we'll set it up with 1 ounce on top is equivalent to 28.3 grams on bottom. And that will cancel out grams top and bottom and leave us with ounces. Okay, I'm running out of space rapidly, so I'm going to just shift some things around here to make a little bit of room. Just going to take all this and move it up a little bit to make room for us to solve. Okay, so now we're ready to solve the problem. And so we're going to plug in what we were given, 200 milligrams per capsule right here. And then our first conversion is to go from capsules per dose, from capsules to doses. So we have, there's 3 capsules for every 1 dose. Now our next conversion is to go from milligrams to grams. So we know that there's 10 to the negative 3 grams in every milligram. So we did that one. And then our next conversion is to go from grams to ounces. So right here, we know there's 1 ounce for every 28.3 grams. And now we're ready to go back and check to make sure our units cancel out, that our dimensional analysis didn't lead us astray. So here we have milligrams, cancels with milligrams down here. We have capsules and capsules canceling out, and grams, top and bottom, cancel out. So we're left with doses in our denominator and ounces in our numerator. So our answer will be in ounces per dose, which is what we wanted to find. So we set it up correctly. Now we're ready to plug it into our calculator. And then after we get a calculator answer, we'll check the sig figs. So let's see. I ended up getting 0.021201, etc. on my calculator. But we know that's not the final answer. Calculators don't know how to round to sig figs, so we need to go back and do that part. So in our starting value, we have 3 sig figs. These zeros both count because there is a decimal point, so we have 3 sig figs here. 3 capsules per dose, that's a defined quantity, so there's infinite sig figs. It's a defined quantity because you can count exactly 3 capsules per dose, so there's no estimating. Metric system prefix conversion is infinite sig figs. And then here we have a metric system to English system conversion. It's not centimeters to inches, so that means we have to count the sig figs. So there's 3 sig figs in 1 ounce, 1.00, and there's 3 sig figs in 28.3. So our fewest number of sig figs in this whole problem, and it's all multiplication division, so our final answer will just be limited based on whatever measured or inexact number has the fewest sig figs. Our fewest sig figs is 3. So our last sig fig here will be the 2. We look to the right and it's a 0. So our final answer will be 0.0212 ounces per dose. And again, just in case you're having trouble with my handwriting there, I was trying to squish it in at the bottom. It's 0.0212 ounces per dose, and that's rounded to 3 sig figs. Okay, another example, something you'll occasionally see, is what do you do if you have units raised to a power? Like if you're converting something like cubic centimeters or squared inches, how do you do those conversions? Because you have these units that are cubed now. To do that type of conversion, you have to raise the conversion factor to the same power. So for example, to convert 1,255 cubic centimeters to cubic inches, shown here, we want to convert 1,255 cubic centimeters to cubic inches. We're going to use our same conversion factor between inches and centimeters that we always use. 2.54 centimeters equals 1 inch. But because we're dealing with cubic units here, as our given and what we want to find, we have to cube everything in the conversion factor. So you put parentheses around each part of the conversion factor and then apply the cube. So what this does is 2.54 ends up getting cubed and the centimeters end up getting cubed. And same thing with inches. 1 inch ends up getting cubed. The 1, which 1 cubed is still just 1, and the inches ends up getting cubed. So you end up with a conversion factor 2.54 cubed, and now that's cubic centimeters, equals 1 inch cubed. And we know the 1 is also cubed, but 1 cubed is just 1, so we oftentimes don't write that extra cubic in. And now you have a conversion factor to go between cubic inches and cubic centimeters. So when you plug this in as a conversion factor, don't forget to cube 2.54 in your calculator. So we'll do an example problem. Actually, let's solve this one first. And I'm just going to open up what's called a whiteboard quick so I don't run out of space like I did last time. Okay, so we were wanting to go from (12,255) cubic centimeters to cubic inches in this problem. So we're going to do the same thing we always do. We're given 12,255 cubic centimeters, and we want to find what that is in inches. We're going to make a plan. So we want to go from centimeters cubed to inches cubed, which means we're going to need a conversion factor that has inches cubed on top and centimeters cubed on the bottom. And our conversion factor to go from between inches and centimeters is that 1 inch equals 2.54 centimeters. And to turn that into cubic inches and cubic centimeters, so we can use it in this problem, we need to cube everything. So we get 1 inch cubed equals 2.54 cubed centimeters cubed. So now we're ready to set up our problem and solve. So we're starting with 1,255 centimeters cubed. And here the cubing's already been done, so you don't have to cube 1,255 again. Times our conversion factor, which is right here. And we want the inches part on top and the centimeters part on bottom, so that centimeters cancels out. So we have 1 inch cubed, 2.54 cubed centimeters cubed. So to solve this, you'll take 1,255 times 1. And again, the cubes have already been applied, so you don't have to do it again. And then down here, you're going to divide it by 2.54 cubed. And sometimes I know students like to do the cubing part ahead of time. So 2.54 cubed (16.387.064) cubic centimeters when you cube 2.54. I like to wait and do this as just part of the problem because I don't want to have to worry about all these sig figs getting cut off. This is supposed to be an exact conversion, so I don't want to be accidentally rounding 16.387 yada 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 to too few sig figs and have it affect my final answer. So if I just keep it in my calculator, then my final answer won't be rounded accidentally, and I can round my final answer like it's supposed to be. So 1255 divided by 2.54 raised to the third. And I get 76.58479 and on my calculator. We forgot to check our units here. Cubic centimeters and cubic centimeters cancel out and you're just left with cubic inches, which is what you wanted to find. So we have this number on our calculator, and the last thing we always want to do is check the sig figs. So here we have 4 sig figs in 1255, and inches to centimeters, that's an exact conversion. So our final answer should have 4 sig figs. So the 8 is the last sig fig, 1, 2, 3, 4. We look to the right to see if we need to round it. It's going to stay an 8. So your final answer, 76.58 cubic inches. All right, let's go back to PowerPoint. Okay, we have another practice one of these. So see if you can try setting this one up on your own. And then of course, I'll go through and set it up. Pause the video if you need to. So postage stamp is 0.61 inches squared. How large is the stamp in square centimeters? So this is a conversion problem where you have units raised to a power. So here are given 0.61 square inches. And we want to find that value in square centimeters. So if we work out a plan, we want to go from square inches, which we're given, to square centimeters. And we know our conversion factor to go from inches to centimeters is that there's 2.54 centimeters for every 1 inch. But we're dealing with squares of both of those, so we need to square the conversion factor. And since the square is outside the parentheses, it's going to apply to the units, which is great because we want to end up in centimeters squared. And it's also going to apply to the number. And since 1 squared is just 1, it won't affect the per inches squared. Okay, so let's check our units once we set this up to solve. 0.61 inches squared times 2.54 squared centimeters squared over 1 inch squared. So if we check our units, inches squared and inches squared cancel out, and we're just left with centimeters squared, which is what we want to find. So now I'm going to multiply 0.61 times 2.54 squared. So I like to use lots of parentheses on my calculator to make sure that it keeps the exponents and the powers next to the numbers they're associated with. So I'm going to put 2.54 raised to the second inside parentheses just to make sure that my calculator doesn't accidentally square like the whole answer. So 0.61 times 2.54 squared with the 2.54 squared inside parentheses. And I get 3.93547 and so on. And that's now in units of centimeters squared, but we're not quite done, right? There's always sig figs you got to go back and check. So we have 2 sig figs in our starting number, And then this conversion is between inches and centimeters, which is an exact conversion. So that means our final answer will be limited to 2 sig figs. It's all multiplication division, so the final answer will be limited to the number of sig figs as whatever value had the fewest sig figs, which was 2 in this case. So we look to the right, it's a 3, so it's gonna not be rounded up. So our final answer is 3.9 centimeters squared, the size of a postage stamp. Okay, so that's it for unit conversions. If you want extra practice, I post end of chapter problems as a PDF file in the modules each week, corresponding to each chapter. So these are the questions from the end of the end of chapter questions from the print version of your textbook. So if you want extra practice, like before you do the homework, or let's say you do the homework and you realize that this is something that's just taking extra time to really stick, you can check out those practice problems posted on Canvas. Next, we're going to talk about density and temperature scales to wrap up chapter 2 with sections 2.9 through 2.10.